Hi, I'm Izzy from the Conservancy for Cuyahoga Valley National Park, and today we are going to be acting like engineers from our own homes and thinking like scientists working to solve real-world problems. Before we do that, I'm going to teach us how to use our engineering tools. One tool that an engineer may use is something called a topographic map. A topographic map, as shown here, uses something called contour lines to give us a 3D picture of what the elevation of the land may look like. To show you what I mean, we are going to be making our very own topographic maps. So for these first activities, you will need a couple of things found around your house. You will need some Play-Doh, or I'll provide a link to some DIY Play-Doh if you don't have any in your house, a pencil, a ruler, a plastic baggie, some scissors, tape, a marker, and a Tupperware container. Alright, so for this first activity, you will need a washable marker and your own hand. What we're going to do is pretend our hand is something called Knuckle Mountain. So looking at our Knuckle Mountain, where are the peaks on this mountain? What I want you to do is to take your washable marker and draw X's on the highest point of your hand, so the highest points on your knuckles. After you are done drawing your X's, go ahead and draw some lines around all the points on your hands that are the same elevation. This may be 1 or 2 circles around your individual knuckles, or maybe a couple of circles around all 4 of your knuckles. And at the end, you should have something that looks a little bit like this. So this is a map of Knuckle Mountain, and when I open it, even though my hand is flat, can you see where the peaks of our knuckles are? Can you get a picture of what our hand looked like when it was closed in a fist? What we did is we made our very own topographic map of our own hand. Using these contour lines that we drew on our hands, we were able to give ourselves a picture of what our flat hand looks like when it's closed in a fist. So now that we have made Knuckle Mountain, we are going to move on to Play-Doh Mountain. So using our Play-Doh or a DIY Play-Doh, we are going to shape it as best as we can into the shape of the mountain that we would like. After we have made our mountain, we are going to take a ruler and a pencil. And holding a ruler over the mountain, we are going to draw circles around the mountain every 2 centimeters. So holding up your ruler, you can take your pencil and just draw lines as best as you can around the whole mountain. When you are done, your mountain should look something like this. As you can see, I have used my pencil to carve circles around my mountain every 2 centimeters. Next, we are going to need our plastic baggie and our Tupperware container. So taking our plastic baggie, we are going to cut along the edges like this so you can open it and make a flat sheet. We are going to take that flat sheet and tape it on top of our Tupperware container so it's flat across the surface like that. And we are going to take our Tupperware container and put it over the top of our mountain. Now that we have the Tupperware over the Play-Doh, I want you to look over the top of your Tupperware, and you should be able to see those lines that you carved onto your Play-Doh. What you're now going to do is you're going to take your marker and you are going to try to trace those lines to the best of your ability. For this step, it is really important that you don't move your head because that can mess up the outcome of your map. So you're going to take your marker and you are going to trace the lines around your mountain. So now we have our topographic map of Play-Doh Mountain. But is this map complete? For my map, I'm going to add a couple more elements. So I'm going to add a name to my mountain. And I'm also going to add a compass. Alright, so let's pretend we are going to hike on Play-Doh Mountain. Would you rather carry this 3D model of Play-Doh Mountain or carry a topographic map? Now let's think, for example, instead of hiking on Play-Doh Mountain, we are going to hike on Mount Everest. Would you want to carry a 3D model of Mount Everest? No, it would be way too big to carry in our hands. A topographic map is a great way to see how steep or how flat land is without having to carry this big 3D model of the land. Here is a topographic map of the Cuyahoga Valley Environmental Education Center. On a topographic map, steep sections on the map appear as lines that are closer together. Meanwhile, flatter sections are portrayed by lines that are further apart. Can you find an area on your own on the CVEEC where the land is steep? What about flatter? Now look at your map of Play-Doh Mountain for a minute. Can you point out sections where your mountain was steeper or less steep? Now look back to our map of the CVEEC. How can you tell where the top of the valley is and where the bottom is? On this map, you can see some numbers. So right here we have the number 1,000, and right here we have the number 800. These numbers tell us the elevation. So higher numbers represent higher elevation and lower numbers represent lower elevation. So going from 1,000 to 800, we would be going downhill on this map. So let's imagine that it begins to rain at the CVEC. Which direction would the water flow? Due to gravity, water would flow this way in the downhill section. What would water carry with it? We will discuss this in our next activity. So now that we have learned to use our engineering tools, we are now going to think to solve problems that real-world engineers face today. Before we do that, first I'm going to show you a couple of pictures at the Cuyahoga River at CVNP. As you are looking at these pictures, think which one is more natural? Which one might have a man-made structure in it? As you're looking at these pictures, also think, why is that man-made structure in place? So for this experiment, you will need a couple of things. The first thing you will need is a disposable baking tray. As you can see, I have filled this baking tray with sand. You can also use dirt and some toy Monopoly houses, but you can also use toy Lego houses or whatever else you may have in your home. As you can see, I've also cut a hole into the bottom of the baking tray, and this will be used to drain water out, which I will show a little bit later. You also need an empty jug. Here I use an empty lemonade jug, and I used a push pin and I poked holes into the top of the jug. I've also used a Tupperware container to prop up this aluminum baking tray, but you can also use a book or any other item that is the appropriate height. We also need a couple of crafty items, so I have some pipe cleaners. I have some squares that I cut out of felt, but you can also use any sort of cloth that you would like. And then also some stones I just found out around the yard. So let's pretend that our houses on our stream table are a community living on a hillside. So let's watch what happens as we make it rain on this hillside. So as I'm pouring water onto the stream table, pay attention to what's happening to the sand on the stream table as well as the houses. So looking at our stream table, what happened to our community? As you can see, as water went down the slope, it carried down the sand with it. This is a process called erosion. Looking at the houses, most likely your community was also affected by the erosion process. This is a problem that engineers face today, and they have a variety of techniques used to help slow this erosion process. We will go over a couple of erosion techniques next. So engineers may use a variety of techniques to slow erosion. One technique that an engineer may use is something called a riprap. This is a rocky material that is used to protect the surface. Another interesting technique is reforestation. This is because plant roots help hold the soil in place. A third technique that engineers may use is something called an erosion blanket. So here we have a couple of different erosion techniques that are going to help our own hillside community. The first thing I'm using are some stones that I found in the yard, and these will help represent the riprap. The pipe cleaners are going to represent reforestation, as they are going to mimic the plant roots. And finally, I have my felt squares, and these are going to represent the erosion blankets. So take a couple of minutes to brainstorm how you feel you can use your materials to best slow erosion on your community. When you are ready, you can arrange your materials on your stream table, and we are going to make it rain one more time. And again, watch the movement of the sand and the water as it is raining on our community. So compare this outcome to the outcome of your original experiment. Was your erosion control measure successful in slowing erosion on your hillside community? Which erosion control measures work the best? You can repeat this experiment several times, arranging the tools in different ways to see if you have a better outcome in controlling your erosion. Now think back to the picture that I showed you at the beginning. Based on your experiment, do you think this will be successful in slowing erosion? Now that we have learned about erosion controls, can you think of any erosion controls that are used in your own neighborhood? So today we learned how to use a tool that engineers use to figure out the elevation of particular landscapes, as well as thought-like engineers to solve real-world problems caused by erosion. Scientists are finding that heavier rainfall events are happening more often and more intensely, especially in the Midwest. Therefore, erosion is going to become a more prominent issue, and thinking like an engineer is going to be more important than ever. Thank you so much for tuning in. I hope you learned something and had a little bit of fun.